In steam boilers, a constant water level is the key to reliable operation and high steam quality. There are several ways of controlling the amount of water in the boiler. In this task, we'll explore the three most common and offer an alternative solution. The first strategy is also the most simple. Here, the water level is regulated by switching feed pumps on and off based on input from a level switch. When the water reaches the on level, the pumps immediately start pumping large amounts of water into the boiler. While this is a very inexpensive way of designing a system, the strategy has several shortcomings. The sudden rush of cold water reduces the quantity of steam and the steam pressure, causing variations in steam production. The temperature variations also cause thermal stress, which reduces system lifetime. And the abrupt operation with many starts and stops strains the pumps. One way of overcoming these challenges is to regulate the water level with a feed valve, which is controlled by a level sensor in the boiler. The feed valve allows a certain amount of water to enter the boiler depending on the actual steam consumption. The result is a constant water level and constant steam pressure at all times. This strategy, however, demands that the feed pumps operate continuously, and to prevent shaft seals from overheating, a bypass loop must be installed. This increases energy consumption, as the pumps now transport more water around the system than is actually needed to maintain the right level in the boiler. The valve itself is also problematic. It's expensive to maintain and causes pressure loss, which further increases energy consumption. In fact, a rule of thumb states that a valve adds 25% to your energy bill compared to systems without valves. To reduce this pressure loss, a third strategy combines the feed valve with variable speed pumps. The variable speed pumps adjust their operation according to signals from a pressure sensor in front of the feed valve, minimizing the differential pressure across the feed valve. The result is reduced energy consumption on pump operation. But the strategy still relies on a bypass system and a feed valve to control the water level. At Grundfos, we recommend another strategy. By using the variable speed pumps to control the water level directly, feed valves become redundant. And without the feed valve, there is no need for a bypass. The pumps simply adjust their operation according to the demand, offering smooth operation, reduced system complexity, and substantial energy savings at all times. In fact, if your boiler system has a steam production of 20 tons per hour at 16 bar, a pressure loss across the feed valve of 5 bar at 100% boiler load, and a standard load profile, the annual energy savings will exceed 20,000 kilowatt hours. On top of this, you'll be able to size for a pump with fewer stages and a smaller motor, because the pump no longer has to compensate for the loss of pressure across the valve. Overall, the energy savings of direct boiler feed are equal to the cost of a new, expensive feed valve, including maintenance every year. So, to recap, there are 4 main control strategies to regulate the water level in a steam boiler. The on-off strategy is inexpensive, but reduces both system lifetime and the quality of the steam production. The feed valve ensures smooth operation, but increases energy costs due to pressure loss across the valve. The feed valve variable speed pump combination reduces the pressure loss, but still relies on expensive feed valves and bypass systems. But by controlling the water level using only intelligent variable speed pumps, you combine the smooth operation of the valve strategy with the simplicity and efficiency of the on-off system, with lower capital costs and great energy savings as a result.